Welcome, Severin.
Yeah, it's definitely much better to hide here. So I cannot talk about stuff about the 90s because I wasn't there, but I can talk about modern network application development. So let's get started. So today I represent the Institute for Network and Security. We are an research institute at the OST, the Eastern Switzerland University of Applied Science, so easy to remember. The university is in Rapperswil, St. Gallen and Buchs, and is a former merger of these applied universities from there. We research the latest technologies in the areas of networking, cloud and security, and our goal is to bridging the gap between the industry and the foundational research. So about me, my name is Severin Dellsperger. I'm a network and research engineer, currently pursuing my master degree, focusing on software-defined networking. And for those who were here at the last SwiNOG know that I love segment routing and also the network application development. One year ago, around about, I started participating in IETF, and you see here a picture about me and some Swisscom, and maybe, I don't know, no one from the entity, but they also participated here. So let's get started with the tech stuff. So when we talk about network application development, we can see that as a network application cycle. So we have our beloved network, our network devices. We get data from them, we collect them and process them somehow, and then that network application can retrieve this data, do some incredible stuff, and then write back the instructions to the network. So which requirements do we have? So of course we have to have protocols that we can enable data communication between the entities. We have to have the right collectors and processors to collect the data and process them. And of course we have to have the correct APIs. So let's talk about APIs. We have different APIs at different entities. So for example, one on the collector processor side should give an access to the network application so that the network data can be retrieved. Hopefully we have an easy-to-use interface on the network application side so that the user can use the application easily. And of course, we all know that we have interfaces, application program interfaces on the network device side. When we talk about the APIs, we all know that we have some terms we should fulfill. Okay. Again, so of course it should be documented. Let's pray for that. They should be reliable, easy to use and extend, and so forth. When we talk about concepts, we can talk about REST, gRPC, or for example, GraphQL. When we talk about collectors and processors, a collector has actually two jobs. It should receive the network data, so really collect them and make it available for the processors. So this is actually sounds like a silly task, but it's not that easy because often we're talking about a huge amount of data, so it's not easy to scale the collectors. On the other side, we have the processors. The processors try to extract some information out of the network data, maybe process them in another format and save them so that the network applications can use them easily. When we talk about protocols, we have different protocols for different data communication. So for example, between the network devices and the collectors, we often hear nowadays the term BMP, the BGP monitoring protocol. At the IETF, we're using the term young push for pushing data from the network devices to collectors. Maybe use it, or you know it from in another term, for example, just streaming telemetry, model-driven telemetry, whatever. And we have some other protocols, for example, GNMI or APIFIX. Between the application and the processor, we often see HTTP-based data communication. It depends on the REST, on the API, is it REST or GraphQL or gRPC, whatever. Then between the application network devices, we all know Netcom, RESTCom, it was established a long time ago. Nowadays, we also can talk about GNME, GNMSC, and SSH is still there. So let's talk about the BGP monitoring protocol. For what do we use that? So actually it's used to monitoring and analyze BGP. And how does it work? So actually it works. Okay, I think it's not working as expected. However, how does it work? Generally, we have a monitored router in the middle. We configure it to speak BMP to a so-called monitoring station, which is basically a BMP collector. And then we have our usual BGP sessions to the monitor peers. And what the monitor router will do, it will get real-time updates, notifications, and statistics from the BGP session and send it to the monitoring station. So quite easy. When we talk about network application development, we often also talk about network telemetry. Why? Because network telemetry gives us the opportunity to gain network insight and thus optimize the network management. So I don't want to get too deep into that. If you're interested in this topic, I highly recommend IETF Ops or WG. But I just want to say there are different approaches and technologies. For example, you have to decide, do you want to push or stream the data so that the devices really send the data to the collector, or if you want to do a pull approach so that the collector gets the data and grabs the data from the network devices. When we talk about young push, we have some different types of subscriptions. For example, you can do it periodically, for example, every 5 seconds, or you can do it if something has changed, so an unchanged subscription. So a lot of people say that it's not easy to write a network application. I hope I can prove that or prove them wrong today. And so I want to start talking about Jalapeno. So what is Jalapeno? So Jalapeno is a cloud-native infrastructure platform to enable development of network services or network applications. It was originally developed by Cisco, and after a long time, they have open-sourced it a few months ago. It is built on a microservice architecture, and it has basically one goal. The goal should be that developers can build network applications not only quickly, but also easily. So we will see in a moment that there are many possible applications. For example, you can do applications in the domain of traffic engineering, something with VPN overlays, or also service chaining. So let's talk about the high-level architectures. So again, we have our network. The network feeds the collectors with so-called BMP feeds or telemetry data. Then we have the collector. They send it to the aggregators, where the processors can grab the data, process them, and save them in a database. Then also we have an API gateway. I will talk about that in a few minutes, so that the applications can get the data from the databases easily and then do the virtual instructions back to the network. So let's talk about the data collectors. In Jalapeno, we have two different collectors. One is GoBMP, and the other one is Telegraph. So GoBMP is an implementation of the BMP protocol written in Golang. Of course, it's open source, and the goal is to collect BGP data via BMP, of course. And it parses the different BMP messages types. For example, we'll see that in a moment in the database. We have peer, unicast, prefix, LN, LS node, and so forth. It has the ability to publish this information then in Kafka. This is how it works in the Jalapeno, or also you can just print it into a file or standard output. So if you take a look into the message here, we can see, for example, something was added. In this case, I know it's a prefix which was added, and we have some additional information, for example, which was the router IP, the peer IP. And then, of course, you also can see the prefix line. So let me try again. OK, now it's working. So for example, here you see the prefix and the prefix line. So this structure is quite easily unreadable. So on the other side, we have a second collector, in this case, to collect telemetry data. Telegraph is used. So Telegraph is also open source, was originally developed by Influx Data. And the goal is to collecting metrics, processing and aggregating them, and then writing the metrics or forward them. So I think it's a very cool project because it's plugin based, so you can easily add your plugins. Meanwhile, they have over 300 different plugins. For example, you have different input plugins where you define which is the data source. So for example, you can get it from a HTTP-based service, you can get it from a Kafka, and then again, the same for processing, aggregating, and then on output, you define where you want to write or send the data. So it can be an Influx database or also a Kafka. So when we take a look at how it works in Jalapeno itself, so Jalapeno uses the Cisco model-driven telemetry plugin. It has actually does only 3 things. First, it collects the model-driven telemetry messages. Second, it processes them a little bit and then forwards it to the Kafka. So if you take a look at the configuration, so it's quite easy. So you have your agent configuration, which are channel information about how Telegraph should work. Then here you have information about the Cisco MDT plugin. So you basically define, okay, we want to use gRPC as a transport, and you define the service address, so in this case, localhost and the port. And then you define the Kafka as an output, so you define the broker and the topic. So let's talk about data aggregation. I've already mentioned it, so as a data aggregation, Apache Kafka is used. I don't want to get too much into detail. I think it's well known, but basically it's just a high-performance messaging system where you can easily exchange data between applications. So how does it work? So you can share messages between the different applications. So the one application publishes, so sends messages into a topic. So a topic is more or less just a channel, so you can have different topics or channels on Kafka. And as soon as the application has sent the messages, Kafka will store it in a fault-tolerant way. And then another application can subscribe on this topic or listen on the topic and thus receive the messages when the application itself is ready. So let's talk about the data processors. So we have two different data processors I want to talk about. There are some other virtual processors, but I think it's enough to talk about these. So we have the topology processor. What the topology processor does is it subscribes to the Kafka BMP topic and thus receives the messages from Go BMP via Kafka. And then it takes the different Go BMP messages and creates the ArangoDB collection of documents out of it. So you will see that in a moment that, for example, we have the ls node and ls link collection, which are coming from the BGP link state address family data. Also, when an element was processed, it writes back an information into a topic so that other applications can get informed that the entity was processed completely. So the second processor I want to talk about is another instance of Telegraph. We call it Telegraph Egress. And what it does, it basically just gets the model-driven messages from Kafka and then sends it into an InfluxDB and also per standard to a file. So if you take a look again, so we see here we have another input plug. In this case is a Kafka consumer. So you say, again, which is the broker and the topic I want to receive or messages. And then you have the different outputs. In this case, you have an InfluxDB where you define the URL and other database-specific information. And for the file, it's, again, easier. So you just say which file, and there you go. So when we talk about databases, in Jalapeno they use two different databases. One is the ArangoDB, which is a graph database and basically contains all the BMP data. So when we talk about that, we have really the topology view from in this database. And on the other side, we're using an InfluxDB, so a time series DB, where it contains all the telemetry data. So basically, we assign a time tag to each message. So if we take a look at this here, we can see the different collections we have in the ArangoDB. And so if you take a look at that, we can see, for example, I try to aim the ls node, ls link information, which are really the information which came from BGP-LS. If we take a closer look into that, we see we have 8 different documents in this case, so we have 8 different ls nodes. And if we zoom in again, we can take a look at the document and we see the structure is the same as in GoBMP itself. We see that the action was added, so at some point it was added. And then we have other additional information. For example, this ls node also has a name, in this case, XR4. Recently, we did a proof of concept to stream the interface counters from different routers to InfluxDB over at Telegraph. And you can see, for example, here we have this specific Yang model, the generic counters. And here on the end, you can see that some data was collected. So this is also quite straightforward. Next, I want to talk about the last missing puzzle. So the last missing puzzle is the API gateway. Cisco had already they planned to do it, but actually they never invented one. So we thought after a few projects, we thought that it's necessary to implement one because in our first projects, we just wrote the applications and we used the databases directly. And this had a lot of drawbacks. So actually, there was a lot of load on the different databases. Each app had to do some processing on its own. And I quickly realized, OK, we have to change something and we have to introduce this API gateway. This API gateway, in general, serves as a single point for access, and it really simplifies the data retrieval because you can request data easily. And also, what is new is that you can subscribe on live updates, which was really a game changer. Of course, there are other benefits which are coming by introducing an API gateway. It decouples really the state from applications to the jalapeno, and we can introduce new features. And we started with the caching. So just a quick overview. Of course, it's open source. Of course, it's well documented. It was developed by me and my colleagues at INS. It follows a cloud-native principle, and it's really easy to use because we're using gRPC, so we have like this well-defined contracts via protobuf, and it's easy to maintain because we introduced some Helm charts to install and update the whole environment easily. So how does it work? So actually, you have your applications on top, and they send a gRPC request to the Envoy proxy, and based on the port, the Envoy proxy can forward this request either to a so-called request service or to a subscription service. So let's talk about them. The request service basically allows an app to request any data via gRPC. So if the data, or if you're talking about topology data, so node, link, prefix, whatever, it gets them directly from a cache. I will talk about why we designed it like that. And if we talk about telemetry data, then it forwards basically the information about the Yang model, the filter, and so forth to the time series database. And after that, of course, it returns the information to the caller. So here we see an example of the protobuf definition. So we have a service, this is a request service, and we have different remote procedure calls defined. Let's see an easy example about that. So we have like an RPC get ls node. The ls node takes a topology request and a ls node response. So a topology request here includes a list of keys and also a list of properties. And if the keys are or if you use keys, then you want to really get information from a specific node. In this case, if you omit them, you just say, I'm interested in every node which is available. And the same goes for the properties. And the response is quite easy. It's just a list of ls nodes. So if you take a look at the example here, for example, we send a topology request with two different keys, and we are interested in the key, the name of the ASIN of this nodes, and the ls node response is a list of different ls nodes, which contains the defined properties. So quite easy. Let's talk about the subscription service. So the subscription service allows an application to subscribe for updates via gRPC. So how does it work? So basically, the subscription services watches for these events written by the topology processor on the different topics, and as soon as something gets updated, deleted, or added, it will receive this message and then grab the information, if it wasn't deleted, from GraphDB and returns it to all applications which were subscribed. On the telemetry side, it works a little bit different. So it watches directly on the telemetry topic and extracts the data directly from it. Again, we have a contract, so we have a service division and all the remote procedure calls which can be called. So also here, more or less, it works the same. So we have remote procedure calls where we can subscribe to ls node. It takes a topology subscription and returns a stream of ls node events. So basically, as soon as you send the request, the TCP connection will be opened, which stays open so that the updates can be sent whenever they happen. Again, we follow in the topology subscription the same mechanism. We have strings, we have keys, and we have properties. If you omit them, you're interested in everything. And the ls node event includes the action. So was it added, updated, or deleted? Then a string to identify the ls node, and then all the properties you want to have. again, we have a topology subscription. In this case, it's empty, so this means we want to subscribe to all available LS node and return all properties of them. And so after the stream was opened, at some point we got an update. So in this case, one router got updated and all the properties of the LS node were returned. Let's talk now about the cache service. So the cache service basically was introduced to reduce not only the load on the GraphDB, but also reduce the response time. And we decided to not cache telemetry because just the updates happen too frequently, and also the amount we have of telemetry data makes cache in general unfeasible. So how does it work? So actually it's quite easy. We also recommend to all developers to do the same system. So first it subscribes to all event update topics on Kafka. So it really gets the updates if something was changed. Then it fetches the current state of all existing documents from the GraphDB, and then it can process the update messages if something happened during this time of fetching. So let's talk now about how we can write applications with it. I brought an easy code written in Go, how you can get all the LS nodes, and I hope you will understand it. But actually, it's quite easy. First, you just define your request endpoint consisting of an address and a port. Then the next step is that you dial in, so you really connect to this Jalapeno gateway instance. And then you get a client out of this connection. So on the client, basically the client is the interface or where all the methods are defined. And so we'll see that below that. So first we create a request. So in this case, it's an empty topology request, which means we are interested in everything and all the properties should be returned. Then we can really send the get ls node. So in this case, we're using the get ls node I have used in the former example, and we can use this request which we have crafted above. So it means send a request to the Jalapeno API gateway and give me all the nodes with all properties. And then you can do whatever you want. We have just in our example a pretty print. You can see it's available online if you're interested in that. Or you can just do it in Python. As obvious, it's a lot, it's smaller and it's also a lot easier. We also have developed a few demonstrations, which maybe gives you a feeling about how everything works. So we have a simple CLI applications with basic examples of how to interact with the gateway. And also we have developed an easy example app of just showing a topology, which consists of an easy front end and a backend application. Of course, we are also we wrote a more sophisticated application. So, for example, one in the field of network analytics. I have also mentioned it like 1.5 years ago at the last SwiNOG. So, in this case, you can take all the network topology data and you can calculate the link quality assessment. So how good is the link? How important is it based on the shortest path calculation and so forth. And then also we have introduced that you can do remove links, and then it would automatically calculate how is the link quality assessment with the recalculated or with the new topology. Also, we have introduced a service programming application. So this application can calculate the best service chain in your topology. So basically, you can distribute all your instance or services in the network, and then the service programming application can use this information, also the topology information, to calculate the best service chain and deploy the policies to the network. And also when something changes in the network, of course, it will be notified over the subscription service, and then it can automatically recalculate these policies and, if necessary, also redeploy the policy. The latest application we have developed this year is a graph analyzer. So basically, it takes all the information from a graph and then can give you some properties about the graph, which I think could be quite handy for an ISP to analyze if everything is good or if the network was designed properly. So I'm already at the end, so if you want to get information about the project itself, so if you find everything in our GitHub organization, you find there how you can get started, how to install and update the whole stack. You find also the link about the documentation. So as I already mentioned, so the API is really well documented, and I think it's easy to get started with it. We have also introduced the Go client with example, and also we have a Python client library with examples. And yeah, in general, if you want to get more information about us, what we are doing as an institute, and also about our projects, or you want to get in contact maybe for some research projects or something like that, here you have my email address. And yes, thanks for your attention. And then if you have any questions, I will answer them.
Thank you.
Cool presentation, thanks very much. My question is, what about scalability? Have you tested scalability of this solution, and what were the boundaries and the limits?
Actually, I think if you're already talking about Jalapeno itself or about the API gateway?
About the stack of both.
Okay. I think Cisco did some scalability testing, but actually we have never saw the results, so maybe I'm the wrong person to answer that. But to be honest, I think since I know the stack very well, I think it should not be a problem. You should not have a scalability problem, because how actually the stack is built with the microservices, I think you could really scale it up. Also because it's installed in a Kubernetes environment and everything. But actually, this would be very interesting. So if you should start with that, yeah, you're welcome to contact me. Actually, maybe just to answer, I know that they loaded all the internet routes in it and it still works. So I don't know.
Yeah, cool presentation. You kept that up quite the pace.
Yeah, sorry. Actually,
Simon is going to like that.
Yes, actually, Simon, he did a lot of pressure, so I'm sorry that maybe I talked to the...
So I like that, according to you, everything is very easy. What I saw here is quite a stack, and it involves a lot of moving parts. I was wondering, have you took into consideration providing a Prometheus endpoint to monitor all of that, or some kind of other integration into monitoring? Because as a system engineer, I would be worried about operating all these pieces.
Actually, I'm not from the operations side, but yes, of course, I agree with you that there are many components, and it definitely makes sense that you have a Prometheus or something else to monitor that. But I think this could be added very easily. So, but thanks to letting us know. So I think we will take that in consideration. Many thanks.
Hi. What if you don't have BGPLS? How you would build your topology?
If you don't have BGPLS, you basically would have to replace the Go BMP. Can you give like a proper answer how you could replace this collector, but I'm sure this would be possible.
Or maybe you're aware if any vendor is developing like event-based young push for LSDB for IGPs.
Yeah, it could. I think it could work. It's based on if you have an input plugin, or you can write an input plugin for this information, so you could collect it over telemetry. I think I have done some proof of concepts on event-driven telemetry in Cisco, but I have never like tested in a LS environment. Or
okay, thanks.
But I think it would be definitely possible.
Any more? No? Okay. Thank you very much, Severin.
Thanks.